Okay, guys, this is part two of the emission spectra, the big topic of electromagnetic radiation. From video one, we understood what is the electromagnetic radiation. We also understand how atoms are emitting and absorbing energy, okay, and how atoms are emitting different colors depending on the different frequency that they may produce. Now, in the second part, I told you that I will explain why the name of electromagnetic. Electromagnetic. Okay. So here we have this picture, and I want you to imagine, okay, the energy is traveling, and I show you some examples here with the visible light, with the radio waves, microwaves, UV, and X-rays. Here, this is how these waves are traveling, right? So these will be the waves. So they are oscillating and is distributed like this. If you imagine that we have this Cartesian plane, we have the axis y, and then we access the x. You see? So this is the y-axis, the one that is showing pointing the magnetic field. So meaning that this will be the magnetic. In this case, I am looking this from okay, it's coming towards ours. And in X is the electric field. So is the electric part. So if you see one of the waves will be traveling in this direction towards you, yes. So of course like this, because it's moving like this. Let's put one color. So this is could what we could see if it's traveling towards our eyes, and this will be magnetic. You see how I am drawing this? So this is how the magnetic will be traveling, but at the same time, with the same intensity and with the same energy, with the same frequency, is the electric field also traveling toward us. This is how it would be oscillating. So both at the same time are oscillating and is traveling. Remember that here we have distance between one crest and another crest. Will be the wavelength. So depending on the amount of energy, the wavelength and the distance will be higher or lower, and this is how the energy will be divided, okay? So I want you to imagine, and this is why the name is electromagnetic, because that way is how the radiomagnetic radiation is traveling, okay? I really like this picture because this is how the wave is traveling. So here we could see only one wavelength in one direction, but remember that always electromagnetic radiation is traveling in the magnetic vector y, electromagnetic x. Here they just put this picture to show us in an easy way the size of the wavelengths. So look at the radio waves. The radio waves are bending. Here we have the distance in meters, and this will be 1 times 10 to the power of 3 meters, 3,000 meters. This is the size of the wave, and this is the radio waves, the frequencies of our devices are capturing. Then we have the humans. We could say we are from 1 to 2 meters, more or less. Then we have the microwaves. Remember that all of this is in meters, so this would be 0.02 meters, that would be 1 centimeter. Then we have the size of the infrared radiation is for you to know more or less how it is. And this needle point is getting very small. Here we have the visible, the protozoans. Here we have the bacteria. So this is visible times 10 to the power of negative 6 meters. It's even milliliters, very, very small. Ultraviolet is even smaller. This radiation is special because is one of the techniques we use to measure different properties of organic compounds. It's very important. Here we have the X-rays, is in atomic level. Look at the size, 1 times 10 to the power of negative 10 meters. This is very small. And here we have the gamma rays with in the atomic nuclei. If you see these tiny ones, they are very close to one another, they will have a lot of energy, and the frequency will be very small as well. This is just to show you an example of how they are in their early days. After compare here the size of the different wavelengths and frequencies of energies with our daily life, or maybe for us to understand more or less what is the size of these frequencies and the wavelengths, I want you to see this picture. This is very important, okay? And this is very important because it's zoom in the visible light in particular. So as I mentioned before, we have different wavelengths and we that have different frequencies, and of course will they have different energy. Here we have the gamma rays. Here we have the radio waves. They have the biggest wavelength. Yes, remember that here in this case we are talking about in meters, so we are talking about that 1 times 10 to the power of 8 meters. So this is huge as all the radio waves. And as we go, this getting smaller. As it's getting smaller, frequencies are also getting higher. Okay, the frequency will be more, and also the energy. After the radio waves, we have the microwaves, then we have the infrared radiation, and then we have the UV light. But between the infrared radiation and the UV light, there is something that we call the visible spectrum. And we are zooming in this here. If you can see, I am taking this part and I am putting this here. Of energy is the one that we can see with our eyes, and this is how we could see different colors. So the frequency of the color purple will be higher, smaller wavelength than the color orange. For example, colors will have different wavelength and different frequency, and for that reason also different energy. Okay. After the visible light, we have the UV radiation, then we have the X-rays, and then we have the gamma rays. You cannot see the radio waves with your eyes. It's not possible. Our eyes don't have the frequency to capture these waves. Microwaves, we know that they exist. We can see how the food is moving in the microwave, but we cannot able to see the radiation. There are special goggles where you can detect infrared radiation. But this is the visible light, and this is one I want to show using this picture, okay? The importance of visible light. Because at the end, many colors and many changes that we can see with our eyes are very important for chemistry, okay? Now, let's continue with part 3 of this emission spectrum electron configuration starter. So please don't forget to go to part 3. And if you have more doubts about this, I think that if you check the part 1, I am explaining energy from scratch. So if this is complicated, one, and it will be clearer for you. And if you want to continue here, let's go to part 4. And then we will continue with part 5, where I am solving exercise past papers. Okay.